Welcome. You've lost stuff. Sorry. So I didn't hit record. All right. So the average grade for all stat students is at most 78. Take a minute. Take a few seconds. Can you write down the claim in Mathish? Anybody? So what do I mean by Mathish? What's the symbol we use for average?
X bar.
Now I'm not talking about a sample. The claim about all stat students.
Oh.
What's the symbol for at most?
Less than or equal to.
Good. Less than or equal to. There. So that's the claim in English. That's the claim in Mathish. Okay. Like it. So how would I test this claim?
Take a sample.
Take a sample.
Find your sample mean.
Get the sample mean. I love it. Because we can't talk to all stat students, we can't access all that, but maybe we can get a sample of grades and we can get a feel for whether this is true or not. So, okay. So to test this claim, we can circle this. To test the claim, we sample 91 grades and find the mean of those 91 grades to be, let's say 80. Yeah, I like it. Sigma known to be 14.19. Okay. All right, let me stop for a minute. Oh, boy. So what I'm trying to do is eventually we're going to work t-scores into this, of course, because we're normally not going to know this. But just to get into this, I'm going to use z-scores that we're more used to. Okay. I like it. Now. So what's interesting? All right, let me see if you guys remember what we talked about. Do you guys remember we talked about the two old men in a coffee shop? Did I give them official symbols? I can't remember what the book does anymore now. If they do H1 or HA. Oh. You guys, I don't know if I put the symbols down yet, but this is the null hypothesis. And this is the alternate hypothesis. I'm pretty sure that's one of the last things we talked about were these two things. These two old men in a coffee shop. They always disagree with each other. All right, I really want you to, all right. Let me ask you a question. Does our claim include the possibility of equaling something? Yes. Equal to, right? So it could be equal to. I can never show equality with a sample. Make sure you understand what I mean. If you thought the average age in the class was 20 and you took an average and it was 20, the average of the sample was 20. Does that mean that the claim is true?
No.
No, I don't know. It's just a freaking sample. So I can never prove that something equals something with a sample. I can show evidence that it's not equal to. So if somebody's like, I think the average age of the people in that room is 20, and we go take a sample of 80 people and the average is 73, screw your claim. That's crazy. Is the average actually 73? No, but that's good evidence that it ain't 20. Does that make sense? Okay, maybe.
Makes sense to me.
So you can never prove with a sample that some parameter equals something, but you can show evidence that it isn't, so like it's less than something or greater than something. Okay, maybe. So what does that have to do with anything, Jeff? I don't know anymore. Oh, yes, I do. Okay. The null must always have an equal sign. And the alternate can never have equal sign because they're opposites of each other. So if this guy has the equal sign, this one obviously doesn't. So which one of these, if that's true, which one of these statements are we actually able to show evidence for?
Null hypothesis.
No. Because we just got done talking about the fact that you cannot show evidence for something equaling something else. And since this one won't have an equal sign in it, this is the one I can show evidence for. Now stay with me. Does our claim have an equal sign in it?
Sort of.
Don't say sort of. Does it have an equal sign? How do you say the symbol?
No.
How do you say the symbol? How do you say it?
Greater
Less
than
than
or
or
equal
equal
to.
to.
Less than or equal to. There. Does it have an equal to in it? Hell yes. It said it. Holy shit. Can't get away from it. I don't care that it has a less than into it. If you say, does this cookie have nuts in it? And you're like, well, it's got other stuff. No, it's got freaking nuts. Get it out of here. Right? Well, actually, I'm okay with it. So where should this statement go? Should I put it next to HO or should I put it next to HI, H1?
HO.
Yeah, because it has a freaking equal sign in it, right? All right, so this is the normal process you're going to go through. The very first step is simple. Find your claim, write it in Mathish, put it in the right place. Sorry, I get turned around. So that's got an equal sign. I'm going to put it here. What's the opposite of this? I'm going to put it there. What's the opposite of less than or equal to 78?
The mule is greater or equal to 78?
Oh, so close.
Or greater to 78?
Yeah, it can't have an equal sign, and that already has an equal, so that can't have an equals and be the opposite. Okay. So your claim has to go in one of these two places. Why did our current claim go here? It's got a freaking equal sign. So we have developed this process so that the statement that goes here is the one that I can actually show evidence for. Now, is our sample mean bigger than 78? Is our sample mean bigger than 78? Yes. So why, though, can't I just stop here and go, well, crap, it looks like this guy's right and this guy's wrong? Why can't I just stop right now? Dear God, Jeff, that would be awesome. Why can't we? Can we? Can we just stop now and leave and go get cookies with or without nuts? Is that something we could do? Does someone remember why I can't just stop now? Is the actual mean 80?
No.
No. The sample mean is 80. So the fact that the sample mean is bigger than 78 doesn't mean shit about the actual mean. I don't know what the actual mean is doing, right? No, stay with me. All right. So all right, you ready? All right, this kind of sucks. Let me see if I can consolidate some of this. Have you guys got what you need from here? You guys got this? Okay, I'm gonna erase this. I'm gonna write pertinent stuff here.
Do you need to disprove that?
That's what I was gonna say. Thank you. I'm sorry, I cut you off. I think I know what you're about to say, but what's your question?
That the mean is not greater, or I mean, is not lesser or equal to 78.
So this is so cool. This is how science works. If our claim is this, do we want to find evidence that this is true? If this is what we think, do we actually want to find evidence that this one is true?
No.
No, because if this one is true, what does it mean about our claim? Our claim is
Incorrect.
false. I like it. So that's how science is. We go, I think this is what it is. Let's try to disprove that shit. That's how science works. And to be honest, if we disprove it, we don't care. We're like, holy crap, that's neat. Anyway, sorry. It's a little plug for science. Dun, dun, dun. Okay. Let me see what else I have here. So I got this stuff here. I'm going to move this stuff up here. I'm going to erase all this stuff. You ready? That's why I should have gotten the bigger board, but oh well. All right, so I'm going to move that. So this would be step 1 in our process, is identify the claim and then put the claim in the right place. And yes, if you are an easily offended person, you're already dropped my class, obviously. So it's going to be okay if I say we're going to talk about the hoes and the highs, right? Obviously, we got the hoes and the highs. So which one is this one? That is the hoe. And the high has got to be the opposite of that. I love it. So we already got that. Let me take that away. Now we got room again. So step 1 just lays out what the hell we're talking about. We're talking about a claim and its opposite, right? Okay. Can somebody tell me, remind me, which one of these statements can we show evidence for? Remind me, which one?
The alternate hypothesis.
Alternate hypothesis, I love it. So how do I show evidence? Where on this picture would a sample have to fall to show evidence that the mean is actually bigger than 78? Where would it have to show up to make it obvious that, or make it evidence that it's bigger than 78?
2 deviations up and down.
Okay, I'm with you. What we're going to do as part of this chapter, and to be more closer to real life, is we're going to start to change the definition of unusual based on the situation. So what do I mean by this? If you're in a nuclear facility, you with me? And you see the little needle, it's in the green and it starts going towards the yellow. Are you going to sit and wait for it to get like in the middle of the yellow to go see what's happening? Are you? Your definition of unusual is not going to be 2 standard deviations away from normal. It's going to be a little tiny bit away from normal. I'm getting off my ass to see what the shit that is because I don't want to die. I don't want Godzilla to come. I don't want everything, it's going to be horrible, right? Then King Kong, you got a horror movie and all this crap. All right. Maybe.
So, Godzilla's a great movie.
I don't know. I really wanted it to be. I really did.
Now I have to drop your class because I'm offended.
No, that's fine with me. Bye. All right. No, stay. They could have done so much. Sorry. All right. My God. Anyway, I'll come back. I'm talking about the Kong versus Godzilla. Is that what you're talking about too?
Oh, that one wasn't that good either.
Thank you. Okay. That one was not good.
I had higher
Godzilla
expectations.
was fine. Bryan Cranston was fine. All right. Sorry, everybody. I'm sorry. It's my fault. It's my fault. I have forgotten what I was talking about. Damn, how did I get to freaking Godzilla? Oh yeah, because all right, that's right. If what's a less dangerous? Let's say you're gonna mow the lawn. The minute the grass grows a little bit, are you gonna jump out and mow the lawn immediately? No, you're gonna let it go. You're going to let it go 2, 3 standard deviations above normal. Maybe it just depends on how you're feeling. It doesn't matter. But if you're in a nuclear facility and it's measuring, you might define unusual to be 1 standard deviation away from normal. Does that make sense? And in another situation, like unusual could be 3 because the consequences aren't that big. Okay. So they are going to define for us what unusual is in every case. Okay. Did we figure out what side this is going to be on? I can't remember.
The right side.
Yeah, a sample would have to show up way up here to be evidence that the actual mean is greater. So 80 is bigger, but is it bigger enough? Okay. So is this a one-tail test or a two-tail test?
Two-tail?
How
One tail?
many tails did we just draw? One.
Sorry, I was thinking intervals.
That's all right. I know. Confidence intervals, always two tails, because chop. But here I just went chop. So I got one tail. So it's a one tail test. Become an A. Okay. All right. The second step is a very, very familiar step. The second step says, can I use Z-scores or T-scores or nothing? We've had that come up before, right? Can I use a Z-score or T-score, or is it not normal, right? So there are two things you have to check. One, I just said, is it normally distributed? The distribution I'm working with. Is this a normal distribution? Did I say it was normal?
Yes.
Did I?
Oh, no.
Nope. But is it normal?
10 is greater than 30 and we're
Good.
standard deviation.
I don't care about standard deviation. Just for this question, is it normal? N is greater than 30. There it is. 91 is greater than 30. Check. Second thing is, which standard deviation do we know?
Sigma.
Yes, sigma. We know sigma. Sigma known. So that means I can use what?
Z-score.
Say again?
The Z-score.
B-score, yes. Sorry, I couldn't quite tell which one it was. Let me stop for a minute. Is everybody cool with what just happened? Doesn't that feel familiar? Haven't we done exactly that before? Yes? Okay. It just wasn't the second step in a big ass process, but we've done that thing before. Zort or nothing. Okay, now we know I can define. So here's the idea. And this is what I talked about last time. Does everybody see where I drew that line? We talked about this last time. Not only does it have to be bigger than 78, but as it has to show up in an area that would be unexpected for it to show up if that really was the middle. So if that's the real middle, a sample should show up in here. So if I get a sample show up here, that is evidence that the real mean is bigger. I really want that to make all the sense in the world, obviously. So not only does something have to be different from the mean, it's got to be far enough away from the mean. You're gonna hear me say that so much. Far enough away. Is this far enough away? What's far enough away? How do you tell it's far enough away? Holy shit! I'm gonna say that. You're like, stop saying it. Okay. So now, what do you think? Now watch. All right. If a sample does get here, which one of these guys does it reject? Which one of it does it say, you're wrong, sucker? Which one is evidence that it's wrong?
The alternate hypothesis.
No.
The null hypothesis.
Yeah, it's gonna be the other one, right? You guys had a 50-50 shot. So isn't this evidence that that's right? If I get a sample way up there, that's obviously evidence that this one's right. Right?
Yeah.
If you said, I think the average age over there is more than 20, and we go take a sample, then it's 73. I'd say, I think you're right. Right? Because it was exactly in the direction you thought it should be, and it was big enough to be evidence that you're right. Okay. So what we do, we call this the rejection region. We call it the rejection region because if we get a sample that shows up in there, it rejects. Now get ready, kids. let me say it the technical way first. It rejects the null hypothesis, more affectionately known as it'll reject the hoe. Okay. All right. Report me if you must, but I just like to have a little fun with this stuff. All right. He's talking about hoes. All right, shut up. So the next step. So this step is, what the hell are we talking about? This step is, what are we allowed to use to talk about it? This step is going to be, what is far enough away? What is far enough away to show evidence? So this will be what I call define the rejection region. So the one thing I haven't told us yet that I'm always going to have to give is an alpha. Let's say 0.01, sure. Can you guys, now listen, you got everything you need. Let me underline the things you need to figure out what this is. How many standard deviations up? What's the z-score here? I know it's a one-tailed test. I know alpha is 0.01. That's all I need. That's all you need, guys. Can you figure out what the z-score is for this situation? Some of you guys are like, what the shit is he talking about?
I have a question.
Yes.
So when you give us the alpha 0.01, is it just for this example? Are you saying that we have to use that every single time?
No, you're right. It's got to be given to you. There are going to be a couple problems where they don't give it to you, and we'll talk about why that might be, but they're going to have to give us this, and some of you guys have seen this in earlier, it's called the level of significance also, right? So they got to give us alpha. It's a one-tail test. Alpha's 0.01. Can you use the t-score chart? Right? Doesn't that sound made for the t-score chart? One-tail test, 0.01. It's a t-score chart. I don't care. You go all the way to the bottom.
2.32?
Say again?
2.32?
2.32? No?
Wouldn't it be 2.33?
2.33? Sort of. Why don't you guys do what I say?
Oh, 2.575.
No. You were much closer with 232. It just wasn't right. 233 I would accept, but come on. What does the t-score chart say? Oh, I'm sorry, somebody's pointing me. Okay. 2.326. Can you guys find that on the t-score chart? I really want you to understand. How is a t-score chart set up? Doesn't it say one tail, two tail, correct? What do we always use for confidence intervals? Two tail. But I told you, you can cut it in half and use one tail. This is a one tail test. Okay, I look at the top row. One tail test, 0.01. One tail, 0.01, and then I just go all the way to the bottom, and you get 2.326. You can't help but get 2.326. So, go ahead.
So is that because we don't have degrees of freedom calculated right now, or?
I don't care. What's the degrees of freedom? Wouldn't it be 90?
Yeah.
I can calculate it, but why would I use it? I don't want a t-score.
Oh, I see.
Yes, so be careful. If you stop, t-score. If you go all the way to the bottom, z-score. I can't point in the right direction there. All right.
Once you get to large, is a z-score only?
Yes, the bottom row and the t-score
Okay.
chart are z-scores. Yes.
I see.
Cool. How large does the sample have to be? Ambiguous. Unclear. Uncertain. That's why it just says large. Because it really does depend on how detailed you need to be for whatever study you're doing. So there's a large. Let me stop for a minute. Okay. So what do we got? We summarize what we're talking about. We think this is what would disprove this. What can we use to study this? Z-scores. Where does evidence start? Here. This is where unusual starts for this problem. So each problem is going to have its own kind of definition of unusual. So instead of 2, it's now 2.326. Go ahead.
Is that defined in the problem, or is that something we figure out?
They have to give you this.
Okay.
Yeah. All right. All right, let me see. This so sucks that I have no room. The fourth step, not surprisingly, is calculate the z-scores from the sample so you can see where you fall, right? So let me see. Can I do this? I don't know. I'm gonna try to put step 4 here. 4. Maybe I can put it here because all the data I need is right there. Here's all the data I need. What's the z-score formula? And here's the neat thing. Are you ready? Oh, you guys are gonna love this. You guys already love this. I know, you're all like, oh, good. Do I already have a z-score there? You guys agree there's already a z-score there? I'm about to calculate another z-score. This is something I do for myself, and it's how I teach it. You're not going to see it in a book somewhere. I call the z-score that we calculate, I call it z-star. And the formula for z-star never changes. I mean, the formula for z never changes. Never. It's our data minus the middle divided by the spread. That's what it is. Now, before I calculate this, what do I need to do with this? Did we take a sample?
Yes.
Yes, we took a sample. Are we talking about the sample means? Sample mean. Are we talking about the sample mean? Oh, yes, we are. We're talking about the sample mean. Therefore, what must happen? Can I use this?
No.
No, I'm going to use this. Let me erase this for a minute. So what is the new standard deviation? Somebody help me out. .562. I don't know.
How come we don't figure this out earlier?
What do you mean?
I got 1.488.
Yeah, don't worry. I just said that word out of my, for trying to do it in my head. So don't freak out. I'm just happy I didn't get too far off, did I? Well, sort of. Oh, well, I'll survive. 1.488. I agree with you. Now, the question was, why didn't we do this earlier? Go ahead. You can do it earlier. I don't care.
Oh, okay.
Yeah, it's just that step 4 is when we look at the sample. That's why I normally don't do it until step 4. Okay, but I mean, I don't care if you do it first thing. You can do it first thing if you want to, yeah. And now we can do our z-score. Our z-star is what I call it. This is the z-score from our sample, right? So it's always, what is the z-score formula always? It's always our data, 80 in this case, minus the supposed middle, 78, divided by standard deviation. So somebody help me out. What do you guys get when you do that? Let's see. 1.3 something.
4.
Huh? What is it?
1.344.
Dude, it's not too bad, right? I don't know, man. See, my skill is not very impressive. I understand. It's my one skill. There's like numbers. Good job, buddy. I got a calculator. Go yourself. Now, really, now there's so much shit happening. Are you with me? Obviously, you agree with me. There's a lot of shit happening, but try to compartmentalize it. Step 1 is all about the claim. Step 2 is all about what am I allowed to use. Step 3 is where does evidence start? Step 4, did we make it far enough? Did we make it far enough? Here's the rejection region. That would be far enough away to show evidence that this is true. Did we make it far enough away?
No.
No, we made it right here. And this is another reason why I like to call it Z star, because I can put a little star on it. Yay! So my sample. Sorry, go ahead.
I had a question about this part. I don't completely understand how alpha fits into this because
Oh, what? Sorry?
alpha, it's
Oh, alpha. Yes.
0.01, but then that's where I'm kind of lost.
Where did 2326 come from?
Yeah, so that came from
Came from alpha.
where did I don't even remember where it came from.
It came from alpha, remember? It came from alpha.
On the T chart.
Yeah.
Oh, okay, I see.
So he came into play. He is what helped us set up this.
Okay.
Yeah. So now let me tell you more about alpha right now. So I'm kind of happy that you brought that up and it kind of slowed me down and so I can make sure I hit all the big points. Alpha is the probability that a sample would show up in here, correct? Because what is the area of this tail? What's the area of this tail? You know already. What's the area of the tail? You know what it is. You knew what it was before you even knew that was 2326. What does alpha tell you? The area in... What does alpha tell you? It doesn't talk to me, Jeff. I don't know if it talks to you. Let me be quiet. Alpha tells you the area in the tail. Yes? Alpha tells you the area in the tail or tails. So, what area is in that tail? What's the area in there?
0.01.
0.01. I just told you. Yeah, so 0.01. So that is the probability that something would show up here if that's the real middle, if 78's the real middle. So I had a sample taken that showed up where it should show up if 78 is the actual mean. Let me say that again. We took a sample, it showed up where it's supposed to show up if 78's the actual middle. So I really want you to understand. Any way you look at this, it comes to the same conclusion. We didn't make it far enough away, therefore I can't say this is right. We made it where it should be if 78's the real mean, therefore it looks like this guy is right.
Do we just stop there if the null hypothesis is right, or?
No, you still got to do the last step. The last step is the most exciting step, the step that everybody loves the most. It's writing a conclusion.
Yay.
Yeah. And of course, I'm just now realizing that I skipped a step here that's going to help us on the last step. So let me ask you this. If we would have gotten a Z star that was greater than 2.326, right? If we would have gotten a Z star that was greater than 2.326, what would that have been evidence of? That who is wrong?
The alternate.
No. Where's the null? The null thinks things should be here. So anything that shows up outside of there is evidence against it. So if I would have gotten a Z star greater than 2326, I could reject the hoe. Which means I could have supported the high, right? Sounds like propositions that California recently voted. So but did we find a Z star greater than 2326? Did we make it in there?
No.
No, we didn't make it far enough away. So did we succeed at doing it? No, we failed to reject the hoe. We failed to support the high, right? Don't worry. I know. Don't worry. So here would be the conclusion, and then I'm going to show you the handout that's got all of these steps fleshed out, right? So the conclusion is going to be, we have not found sufficient evidence to, now what was the claim? Of course, I just erased it. Which one was the claim? The null or the alternate? The ho or the high? Which one was the claim?
The hoe.
The ho. So I want to word my conclusion based on what the claim was. So we failed to do this. So we have not found sufficient evidence to reject the claim. Holy crap. That the mean grade is at most 78. See, the last thing you can do is you can plagiarize from the claim, right? All right. That was a lot. So let me show you the sheet in Canvas. I got to go activate it. So before I block all of this stuff, I should be able to sit down, right? You guys are probably still just copying the conclusion. Let me bring my chair back in here. Come here. All right. Let's see. Are you guys excited? Yay, this stuff seems awesome, Jeff. No, I understand. So let me show you. If you go to Canvas now, you will see a Unit 9 module. And it says hypothesis steps explained. That sounds hopeful, right? All right, look at all this. All right, so let me open this up a little bit better here. No, let me just do it this way. Hold on. Blah, blah, blah. Here we go. Strangers in the night, exchanging their clothes. All right, where is Dadgummit? Donde está? Hold on, everybody. Where's my sheet? There are you. All right, I don't know. So let's just do it this way. All right, that's fine.
Is that Frank Sinatra?
Could be. You guys, you know the, yeah, you know the song "Strangers in the Night." Strangers in the night, exchanging their clothes. It's not
Yes.
exactly. It's not the real song. Isn't really exchanging clothes, but it will. All right. Here we go. Okay. So you guys can open this up for yourself. Did I? Is this the one where I did? Okay, good. So what I try to do is I gave us a sample problem to work on, but notice I have stuff written in each part to remind you. So in black is kind of like reminding you the important, I can't remember what the black and red was, to be honest. Maybe I just was trying to, yeah. I think red is more philosophy, conceptual. Black is more technical. Yeah, I think that's what I was trying to go for. Okay, so on a test or a quiz, I will give you each step. I will ask you these questions. I'm not going to just say, do the 5 steps. So you're not going to have to memorize the 5 steps. Okay.
What's this sheet called again?
Oh, let me show you. So it's under Unit 9. It's the only thing under Unit 9.
Oh, okay, that was it.
Yeah, hypothesis steps explained. Yeah. Oh shit, where'd it go? There it is. What time is it? Okay. So let's see. You guys try to get as far as you can here. Let me make sure this. Yeah. Yeah. Okay. Let's just turn around the correct way. Okay. So I really want to make something very, very clear. 12.45, what is that? Statistically, what is it? It's a mean, but what kind of mean? Where did it come from?
A sample mean.
It's a sample mean.
Sample mean.
I love it, sample mean. Would we ever make a claim about a sample mean?
No.
Of course not, because we see it. So I'm gonna claim that I'm holding a pen. Good job, Jeff. Way to go on a limb. I claim that I have hair. Okay, good job, Jeff. We can see that. So we're gonna make a claim about something we can't see. So this number will never show up in part A. Part A is about a claim. Does somebody know what the claim is? What would I write here?
It's the first sentence.
Yeah, I don't want all that English shit. I want beautiful math. Beautiful, compact, efficient math. We think that the average time the coyotes live, if given more room to roam, is longer so we think that their average should be bigger than what?
Someone in the chat said 10.15.
Oh, yeah, the chat, since the last update, it doesn't tell me when I'm getting a chat anymore. Yes. Does that make sense? All coyotes in captivity live this long. I think that the coyotes live longer if they're given more room to roam. So I think that the mean for those who give more room to roam is more than the standard 10.15. Does that make sense? All right, I like it. So where is that going to go? Here or there? Low or high? Null
High.
or alternate? Hey, oh, yes, it does. Why does it go in the high?
Because it's not
Doesn't have an
equal.
Doesn't have any equals. Bam. So what's the null hypothesis statement going to be?
That the mule will be less or equal to 10.15.
Yes, kick ass. If this is greater, the other one's got to be less, and it's got to have an equals. If the other one does not have an equals, they have to be complete opposites. I love it. Is everybody with me so far here? Okay. There is such a thing as a two-tailed test. There is, and we're going to do an example, but this is still, what kind of a test is this? Is it one or two-tail?
One.
Yes, because the tail is going to be up here, right? Greater than. To show evidence for that, I would only care about this side here.
What would a two-tailed test look like?
Ah, look at you. I was about to ask that same question. So what would a two-tail test look like? So it would have to be, what if I claim that the mean is 7? What's the opposite of that? Don't write this down, by the way. Just look at this. What if I claim that the mean is 7? What's the opposite of that?
The mean is less than or equal to 7.
No, of course not. Come on.
Oh, sorry. Less than 7.
Nope.
Greater than 7.
All right, let me say yes. Now put all of that together. Because what's the opposite of equal to something? More or less. Or what's a better way to just say the opposite of equal? Not equal to. I love you guys so much. Not equal to. So if you end up with this, this is a two-tailed test. How do you show something is not equal to something else? It's more or less. Two tails. That would be what a two-tailed test would look like. All right. Is that all right? So that was a good question. That's what it would look like to be a two-tailed test. So that's not what we have here. We don't have that here. We have a nice one-tailed test. All right, you guys do the next part. That should be pretty quick. All right. So is this situation that I'm working with normally distributed?
Yes.
Yes, 41.
It is 41 greater than 30. Central limit theorem says have fun. Which standard deviation do we know?
Population.
Sigma.
Oh.
Therefore, yeah, population. Yes, population standard deviation. So which thing can we use, Z or T?
Z.
Z. All right. And this makes sense. Of course, this is the second step, because the third step, I've got to identify where my rejection region is. Now I know I can use a Z-score for it. So unfortunately, I still use 0.01 here. Oh, yeah, but there's going to be other alphas, obviously. But alpha's 0.01, one tail. It's the same Z-score we just used. Unfortunately, I'm sorry. I'm boring. Right? Alpha's 0.01. And it's
326.
yes, 2.326. So look what I say right here. Put it into words also. So if we get a Z star, that is where we can reject the null. What does it take to reject the null? It's got to be smaller than something, bigger than something, equal to something.
Smaller than.
No.
Oh, bigger
Than
than
10.32.
Greater than 2.36.
So if our Z star is greater than 2.326, we can reject
The whole
no,
and support the high.
support the high. Yeah. Real talk today, kids. Life lessons. All right. So again, I really want you to get this. If the 10.15 really is the mean, then any sample I take should show up close to that, right? Does that make sense? If I take a random sample and the actual mean is 10.15, then I should get a sample mean that's close to 10.15. So what does it mean then if I get a sample that's not close, it's far away? That would mean that this is probably not the right mean. Is there a chance I'm wrong about that? Of course there is. This is statistics. This is the most honest math. It's like, dude, I think so. Right? And people hate it for that reason, but it's freaking honest. I love it. So now I know how to interpret the results of calculating a z-score. If it's more than this, that looks like this one's wrong. That looks like this one is right. If it isn't more than that, then I can't say this one's wrong, and I cannot say this one's right. Okay.
Could we break down B or sorry, finding the z-score of the population?
Wait a minute. What do you mean?
For B?
For B?
Yeah.
All right. What do you mean by breakdown?
Like, can we find the z-score right now?
We're going to find a z-score. That's part D. We're going to find the z-score for our sample. Yeah.
Okay.
Yeah. Population we wouldn't really find a z-score for because we would know all about it. So I tell you to summarize the sample information just so you get all the parts you need. What's X bar? What's X bar?
12.45.
Good, 12.45. It's the sample mean. And sigma? Sigma?
4.27.
4.27. Okay. And of course, we always need the standard deviation that works for groups of size, in this case, 41, right? Yeah. So whatever the heck this is, I would say about 0.6.
0.667.
Oh, cool. All right. 0.667. Everybody with me so far? So this, I tell you, this, of course, you have to do this, right? Because we took a sample, we're talking about the sample mean. Of course, I got to change the standard deviation. And then I can do my z-score, which the formula never really changes. My data, we found 12.45, minus the supposed middle, right? 10.15. So it's always going to be the number that comes from up here. That's the supposed middle. The middle we're testing, divided by the new standard deviation. Let's see, 2.3, 3.5, 1.15 times 3 is 3.45.
Yeah, that's what I got.
Dudular. Sorry. Look at Jeff go! Jeff knows math. That's amazing. What does he do? He's a math teacher. Oh, okay. Well, duh. All right. So look, you can either look at it right here. Did we hit the requirement to be able to reject the null and support the high?
Yes.
Yes, and you can also look at it visually. Here's 3.45, right? Did it make it into what we call the rejection region? Yes. So guess what happens if you make it into the rejection region? You reject the null. You reject the ho. So we reject the null. We support the high. That is our quick little thing we can write right now. It's the results of what we just did. We'll talk about this here later, I think. Don't worry. We're going to talk about what that is. I think you guys can handle it right now. I don't know. What time is it? All right, real quick. Somebody help me out. What is the area of this tail? Do you guys remember? What's the area of the tail of the rejection region?
0.01.
0.01. Beautiful. So the same way that alpha is the area in the tail that this z-score makes, the rejection region z-score, the p-value is the area in the tail that our z-score makes. So can you guys figure out the area in the tail of 3.45? What's this little tiny area up there? Oh, this is old school. You got to look back at your z-score chart. all that kind of business. Anybody?
Is it 0.0003?
Yes. It is. If you look up 3.45, you get 9997, and you have to do 1 minus that, of course, to get the area up here. So the p-value in this case is 0.0003. What the p-value signifies, that is, it's not exactly this, but it is related to the probability that we're wrong. Basically, that's not even, it's roughly that. It's the chance that a sample would end up where ours did if this is the right mean. Do you understand? Let me put that all together again. That, the p-value, so this is the probability that we get a sample where we did if this is the real mean. So does it seem likely that this is the real mean? That's the probability that we would do what we just did if that was the real mean. We did what we just did. So do you think that's the real mean? Is that very likely that this is the real mean? It's freaking 0.0003. It's 0.03% chance that we would do this when that's the real mean. So what's more likely? That's not the right mean. I love you guys so much. Come on. Does that, no, that doesn't make any sense. That is what the p-value represents. The probability that our sample would show up where it did if this is the real mean. That is that a high probability? Anybody? Is that a high probability?
No.
No. So what's
It's
more
really low.
likely? This is the real mean, or this is the not the right mean? What's more likely is that's not the right mean. What's more likely is the real mean is more than this. So that's why we support the high. In fact, which one was the claim? Which one of these was the claim?
The high.
The high. So I want to word my conclusion. Screw this. I want to word my conclusion based on which one was the claim. So how does my conclusion go? We have found, because we support, we made it. We succeeded. We have found sufficient evidence to support the claim that plagiarize, right? I'm sorry to all my English faculty colleagues, but you can just go up here and just write down what the claim was. What was the claim? That northern Minnesota coyotes live longer in captivity if they're given more room to roam. So I'm not going to write all that shit out because I already did, right? But that's what you would write down here. Do you guys understand what I'm saying?
This is the first and only time a teacher's told me to plagiarize. I love it.
I know. What context was it told to you in? Was it a very narrowly defined region which you were allowed to do it in? Yes?
I'm thinking I'll just run with it.
That was the correct answer for you, but not for me. Stop it. All right. Now, you don't have to plagiarize. You could just kind of write in your own words what the claim was, but that doesn't really make sense. Just don't say we have found sufficient evidence to support the claim, period. That's not good. I need to know what the shit the situation was. I need to make sure you understand what the situation was. Okay. All right.
I'm a little confused for why we support the claim, because if the claim was that mu is greater than 10.15,
Yes.
we got 3.45.
No, stop. That is a mean.
Uh-huh.
What's 3.45?
A z-score.
A z-score. This tells me that the sample we got was 3.45 standard deviations away from the supposed middle. I really want this to make sense. So this is what the middle is supposed to be, correct? This is what the average is supposed to be.
Yes.
We just got a sample average that was almost 3.5 steps above that. I mean, holy shit. I really want this to make sense. So the fact that this is such an unusual place to be. At this point, you guys all know that a 3.45 z-score is like, holy shit, yes? Because in this specific problem, where does unusual start? Here. So I really want this to make sense. If the real mean is 10.15, I would expect the sample to show up in here. If a sample shows up out here, that would be really unusual unless the mean is not actually 10.15. Does that make sense? If we think the middle is around 10.15 and we get something up here, that is evidence that that's not the right middle. That is evidence that the picture really looks more like this, maybe, where the mean is higher. Is this evidence that the mean is 12.45? No, you can never. I'm sorry, you're good. You can never show evidence that the population mean equals something just using a sample. You can never do that. So the fact that this z-score was so big, and it was definitely bigger than it needed to be, to show that our sample got into an area it should not have if this mean was correct. So what is our conclusion then? That mean is not correct.
So
Now, what
if,
does it mean in terms of, I'm sorry, go ahead.
if the z-score was lower, would it have been like the opposite of the situation or the
Yeah, we would have failed to reject the null. We would have failed to support the high. We would not have been able to say this.
Oh, okay. I think I'm piecing it together now.
Yeah. So what does that mean? What does that mean should happen at every zoo or wherever else that holds coyotes? What should they do based on this clinical study? You could do it. What did we just prove? What's better for coyotes? What did we just show
More
really
room.
strong evidence for? Sorry?
More room.
More room. Exactly. This is evidence that more room will help coyotes. Less room harms them, causes them to have less lifespan, which kind of makes sense, correct? So, but anyway, maybe. So again, this would be if somebody said it was clinically proven to, this is what clinically proven means. Clinically proven does not mean proven. It means strong evidence was shown. Okay, I like it, maybe. In fact, this is a lot like a court case, and I have no idea if anybody paid any attention to a specific court case with an historic result that happened yesterday. That's all I'll say at the moment. So because I really don't want to know if any of you are on the wrong side of history, but this is a lot like a court case. You have to show evidence for something beyond a reasonable doubt, that kind of thing, right? So is there doubt in this, in our result? Yes, there's doubt. There's definitely doubt. There's still a chance that the mean actually is 10.15. But is that a reasonable doubt? Hell no, look at that 0.0003. I mean, that's basically the probability we're wrong. I'm like, damn, I feel really good about that shit. Damn, that is well beyond a reasonable doubt. Are you kidding me? So hypothesis tests are a lot like courtroom trials, like court trials, yeah. All right. I think that's I think that's enough. What do you guys think? Is that enough for today? Yeah? Okay. Somehow I thought you might agree. So remember this, the quiz does not unlock until tomorrow at 5 a.m. and you have until 4 p.m. Friday to take it. I think I gave you an hour. I can't remember now, to be honest. I think I gave you an hour and a half, but I can't remember now. Here, I want to tell you for sure. You can do it, Jeff. There. Yeah, I did. Look at me being nice. Damn. All right. All right. So you are free to go. Let me know if you need to hang out afterwards, and don't forget about the study session tonight. There's a link now for your inbox.
Thank you.
You're welcome.
Freedom.
Thank you.
You can take away dignity, but you can't take my freedom.
Actually, Professor, I have some question.
Okay.
So, in the chapter 8 to 8.2, so if I have the degree of freedom like 83, so what should I pick? Like
80.
83? So what should I pick? Like
80.
between like 80? How about
80?
87?
87. Oh, I see. Yeah. So you should pick the lower one, even if it's
Lower
80.
one.
You should pick 80.
Even I have like 89.
Yeah,
Pick
then you can
80.
maybe go to 90. That's fine. Yeah.
90 is fine.
Yes. But if you have 83, you definitely pick the 80. Because if there's something you don't know, you should always make things worse for yourself, which means making the T-score bigger. So if you take 80 instead of 90, the T-score is bigger, correct?
Yeah.
Okay.
Okay. So how about like 87? So then
If
I
you
can
pick
pick like 90.
I wouldn't worry. Yeah,
Okay.
fine, but you technically should pick 80. Yeah, but it's not gonna be a huge part of what I'm looking at. So, but technically, you should always be more conservative. Go the other way.
Okay. Thank you.
You want? Justin, you okay out there? Are you out there? No? Okay. I'm out of here.